Okay, all right. So in today's lesson, we are going to talk about combining like terms. Some part of it's a review, and then some part of it are regions questions that I want to show you. Okay, and then with one very typical application, word problem like kind of questions that you would have to do on the regions. Okay, so this should take about 2 to 3 days, and with that said, let's get started. Okay, so today's lesson is combining like terms. Now, here you already see that it says we are family. So one of the things I want you to understand is that with combining like terms, it's kind of like families, right? Now, you already know what a term is, right? A term is it's a part of a mathematical sentence, right? That we're separated by plus and minus signs. So the question is, well, how do we combine like terms, right? And this again, not exactly a new topic for you. So I'll give you an example, right? Let's say the best analogy I can give you is, let's say you have to group people by families, right? So one of the first things you would look is by their last names. So for example, now I understand, like, some of your cousins have different last names. I'm not disagreeing with you on that. So let's say, right, we would put these four members of the same family together, right? Because they have the same last name, right? Cook, 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 and Cook, right? Whereas these two, right, Fei Ying and Kacheng Ying, all right, they wouldn't be in the same family. Why? Right, because they spell the last name differently. So even if it sounds the same, right, they might not be in the same family. So that brings us to this, right? What are like terms? Like terms are, okay, the alarm went off outside. Okay, like terms, all right, are terms that have the exact same variables with the exact same exponents, no exceptions. Okay, so what do I mean by that? Let me show you. So here, for example, in the first example, right, the first term here is x squared, the second term is x, and the third term is x to the third. None of these terms are in the same family. Why? You might say, right? You say, well, Mr. Engley, they're spelled the same, right? All three have an x, but it's not the same exponents. So therefore, not in the same family. Okay? Now, looking at this one, looking at the second one, right? Look at xy, and then look at xy squared, right? Same family or different family? Right, different families, right? Some of you might say, well, yeah, but they both have xy, but that's not it, right? That's not only it, right? Look at the y. There's a square, right? Now, some of you say, well, what about the number in the front, the coefficient? Doesn't matter. So imagine if you and your sibling, right, have like, imagine if you and your sibling, right, you guys have different first names. You wouldn't have the same first names, right? But that doesn't mean you're not family, right? So that's the same exact analogy, right? Members of the same family have different first names, coefficients, but they should have the same last name. So even this is 1/2 x squared y, right? Same family, different first names, that's fine, but they're still in the same family. Why? Same exact letters, same exact exponents, same family. Okay, so with that said, what does this mean then? Right? So looking at here, if we were to separate, now typically this would be an activity in class, right? We can separate these by different families. So for example, these two in the same family, right? So is this, right? So is this. But same family, same family, same family, same family, same family, but not this one, right? Its own separate family. There are no members of the family AB, right? Okay, same thing, right? Likewise, if we try this, right, we can separate them into families. One, right? Here's another member of the family, right? They're both x squared y, right? Anyone else? Yep, here's another one, right? So let me ask you guys this. Why is this not in the same family as x squared y? All right, they both have x, they both have y. There's a 2 there, right? Why not? Right, right? This one, the square is not on the x, is on the y. So that's the different family, okay? So let's put that here, here, here. Okay, what else? Anyone else? Let's see. So that's not in many families, right? Okay, how about this one? Let me ask you guys this. What about these two? Are they in the same family? They both have x, y, z, right? And there's a 2 there somewhere, right? No, right? Why? Yep, here it's x squared and here is y squared, right? What about this one? How about these two? Right? They both have x and y. Why not? Right, because there's a square here and there's another square there. Okay, so these 4 don't really have their own, but doesn't have families, all right, that they belong to. Okay? All right, now how are we doing on time? Okay. All right. Now, that said, all right, let's do some practice together. Okay? Very straightforward practice. And I want to show you something that I'd like to do when I solve equations. Okay? And, you know, simplifying expressions. By the way, so combining like terms, there's a fairly general thing that we say when we are combining like terms. A lot of times people just say simplify. And that's what we're doing. We're not solving anything. There's no answer here, per se. We're simply simplifying. Okay? All right. So with that said, let's see. Now, same family. So by the way, so some of you might be asking, okay, so I know that they're in the same family, but how does that help me? Okay, it would help you when you're combining them, meaning you're operating with like terms. Okay? So for example, negative 6k plus 7k, right? So the question is something like, if you owe someone $6, right? And someone gives you $7, right? Like let's say you earn $7. How many dollars would you still have left? 1, right? So likewise, negative 6k plus 7k is, what are you left with? Yeah, 1k, or what's a shorter way of writing that? Yeah, just k, right? Now, likewise, if we look at this one, right? Now, how many different families are going on here? Right, 2, right? What are the 2 different families? Yeah, the n family and the number family, right? So what I'm going to do is I'm going to use a different shape to denote the family. So I'm going to use a square around the n family, and let's say a circle around the number family, and now I can just go by shape. Okay, now if you have different like color pens and pencils at home, you can color code it too. That might be even better. Now what's n plus 9n? How many n's are there? Right, 10. 10n, right? Negative 10 minus 3 is what? Negative 13. And that's it. Simplest form. Okay? And also, whenever you can, put the family member. No, put the term with the letter in the front. Okay, so the letter should go first and then followed by the number or the constant. Okay, same here, right? These 2 are in the same family, so what's negative r minus 10r? How many r's are there now? Right, negative 11r. Okay, right, because that's a 1, right? Remember the invisible 1? Oh man, let's try these. I'm only gonna pick 2, okay? Let's try this one. All right, I'm gonna have my calculator ready, and let's try this one. Okay, and then if you want to try, we can try these 2 in class. Okay, now let's find the families first. Okay, I'm not even gonna get the calculator right now. I got 2 families. The p square family. By the way, notice how when I put the box around them, I include the sign that's in the front. All right, you know that. So here I'm gonna put circles around this. Right, for the p third family. So let's combine them. So that's negative 9.7 p squared minus 9.4. So what's negative 9? Negative 9.7 minus 9.4. Negative 19.1. Okay, all right. Negative 19.1 p squared. All right, let's take care of the p third. So that's negative what is that, negative 3.25 plus 3.1. By the way, if you notice, there's on your, if you're still using a TI-34 calculator, there's a minus sign and then there's a negative sign, right? The minus sign is all the way on the right, right, next to all the other operations. The negative sign is all the way at the bottom in parentheses, okay, just so you know. So there you go, that's the simplest form. Now, here's another tidbit that you need to know. You see how that's p squared and that's p to the third? Standard-wise, everyone puts this in the front first. So here's how you would write this. P to the third, and then minus 19.1 p squared. That's more standard. Okay, that's a p, by the way. All right, so what I mean, letters come first, and when they're both have the same letter, the higher power comes first. Okay, so it's in some sort of order. All right, now let's try this one with the fractions. Okay, that's gonna be crazy. Let's see. Same family, it's the n family. So let's try that. Now, what does that mean? Now, I've defined common denominator for these two. So what is that? 24, right? Yep. So I'm going to rewrite, okay? I'm just going to rewrite everything. So that's 3, so 3 times 27, right? By the way, so one of the things I want to encourage you to do is not be intimidated by fractions, even when it comes to combining like terms, okay? Because as long as you follow what we've been doing, right, step by step, you're gonna be okay. So 29 times 6 times 4 is 24. So 29 times 4 is 116. Yeah, and then let's take care of the family first. So that's negative 81 plus 116. So 116 minus 81, 35, positive, right? Positive 35, 24n. And then I just got this. There's nothing to do here. Okay? All right. By the way, if I made a mistake, you email me and let me know. Okay, now, how are we doing on time? Yeah, it's about that time. All right, so let's do one of these where we solve an equation and then I'll stop. So, okay, all right, now, here you gotta combine like terms. So that's negative 15x equals 45. Divide both sides by negative 15. X, right, cancels out, that's negative 3. All right, let's do one more, Okay, all right, combine like terms, find the same family first. Right? So 6x, 7x is 13x minus 5 equals to 34, yeah? Plus 5. Cancels out, bring down 13x, 39, divided by 13. X is 3, and that's it, okay? All right, so let's take care of the rest in class. Thanks for watching, and I will talk to you guys later. Bye-bye.
OMG, that was so good.